Hi, this is Scott. This is my 577 oral presentation, and I'm on slide 28. This is part six. I just wanted to mention that P2P for the smart grid, is a really exciting area for research. And you can see on 29, you can see that what they're doing here with peer-to-peer. It occurred to me that this wouldn't be a very good way to control security. But in fact, the research shows that what you can do is you can do layered overlays. So you have different micro overlays of a larger overlay, and you can have these layered, many layers on top of each other. And so you've now got a parent-child relationship with different layers where with different overlays, where other overlays are a subset of parental overlay, and by managing how who gets access to these overlays and what data is shared on different overlays, you have a lot of flexibility in controlling what data goes where, and so that's pretty exciting, and something that I hadn't considered, but a good way to use one of the distributed uh, architectures that we learned about. So this is slide 30 is just showing that there's going to be a lot of overlay complexity. I mean, if you look at that in detail, you can see that there's going to be a need to be a lot of different overlays. So slide 31, gets into a little bit of the details of this peer-to-peer system that the project was called Inspire. It's an structured peer-to-peer. And it was built to manage and adapt for node crashes. As we learned in class, peer-to-peer are very adaptable. They're very. We even had an exam question about it, I believe. They're reliable in when adapting to node failures, and administrators can control what subsets of data are shared where, and then the nice thing is that protective P2P mechanisms, it can protect your data. So you have a structured P2P uses the distributed hash tables for efficient storage and replication, and it protects your data and communication through redundancy and replication. And unlike the mesh network that we talked about, uh, peer-to-peer does scale very well. So slide 32, managed peer P2P. It allows for multi-layer creation and management of overlay groups. Provides fault tolerances by allowing current and live nodes to publish SCADA, which that's just an acronym for your control messages. And P2P overlay networks can be scaled to millions of nodes. The P2P protocol extensions exist to enable secure DHT and encrypted or digitally signed exchanges using PKI. So again, the nice thing about this is that I'm not going in a different direction. The PKI that I spent so much time talking about is directly applicable to this P2P. And then the nice thing is that peer-to-peer, you can have intelligence built into this that just like we talked about in class, that can adapt to problems with nodes falling out, nodes not being reliable. All of those sorts of things can be built into this, and can help you with your smart grid. And you're carefully managing your security, and you have you can use P2P extensions to have an optimal use of network bandwidth. So let's go to slide 33. Thank you. I apologize, I was a little long tonight, but my conclusions are smart grid is an essential iteration to maintain operational ability and a viable grid for the future. So you can see that systems such as PKI are needed to manage trust. And local control mechanisms, you can have a specific, architecture built for just that specialized need, something like a mesh network that uses IEDs. And for the greater information sharing, capability of the grid, a structured P2P overlay technology holds a lot of promise, and it's uniquely suited to meet the needs of the smart grid, like dependability, scalability, redundancy, and security. So I know I went a little long today. Appreciate your patience. Email me with any questions. I'll be happy to try to clarify. Thank you for your time. Oh, and by the way, the next slide, slide 34, does have all of my references. So thank you. I really enjoyed the class.